Hello wonderful people, welcome to one of the most important lessons of this playlist, debugging. As explained in the previous lesson where we talked about memory and roughly how it works, that was a prerequisite for debugging, the activity of inspecting code in order to find and fix bugs, and that's what we're going to do today. So, first of all, let's see what we got. We start by printing some message on the console to know that the execution started. Then we declare an int and we print its value. We change that value, we print it again. Then we have a condition where we print some message if that condition was true and another one if it was false. Then we end with another message on the console. The first thing we'll address today is what we call breakpoints, and they are these round thingies that I can toggle on this bar in Visual Studio, and they are used to pause the execution when it reaches that line. And we enter what we call break mode or debug time, because yes, there are multiple times in a program's lifetime. So when we write the code, there's the design time. When we build that project and we create the binary file, there's the compile time. And when we execute that executable file, there's the runtime. Debug mode is something like a pause during the runtime under certain conditions where we get to inspect the memory and see what's going on. And that's what we'll use today. As you already know, if we run our project with this button, the execution starts with the first line of code and continues sequentially with the lines that follow after it. So if we run it, we are now in break mode or debug time because we had a breakpoint at this line and the execution is paused at it. So if we look at the console, only the first message was printed on the console. Why? Because the rest of the code has not yet executed. Even the line of code where we are paused at has not yet executed is about to. So this is evidentiated by the fact that we have no value of age is message on the console. What can we do during this debug mode? First of all, we can hover our variables and we can see their values. And this might not seem helpful right now because the initialization is one line above, but if it was 500 lines of code upwards or in another file, it would be helpful. Another useful thing is that we can see some results of operations, like hovering this greater than, we can see that it's true. The value of age, 20 is greater than 18. So this is a simple one, but in some certain conditions we can see long chains evaluated immediately, and that's nice. The next thing we can do during this time is to temporarily change the values of our variables. If I continue to run my program, the age variable will get the value 40 and it will go through the if because 40 is greater than 18. But what if I wanted to force it to go through the else? Maybe I want to test something. I'd have to stop the execution, modify the code, compile it again, run it. Maybe I have a login page. Maybe I need to navigate some pages before I get the execution in the same point again. All that, it's annoying, time consuming, all that. So instead, I can just hover my variable, I can double click it and I can modify it. Done. And now it will behave as if it had value 16. Another example would be if you have a very large array, maybe 1000 products, and you want to see the total of the 500 product. What you'd have, maybe a for loop, you'd just modify the value of I to be directly 500 and done. As you can see, the text of our button changed to continue because we have to have a way to resume the execution. And if I click it, the rest of the instruction will execute and the program closes. So they all executed. But if I put another breakpoint and I run it again, it stops at the same breakpoint again, the first one. Then if I click continue, it stops at the second one. And we can see that on the console, the last message is not yet printed. So we have the same scenario of not yet executed. So when you have multiple breakpoints and you click continue, it just continues until the next breakpoint. It stops at each breakpoint. Next, what if we wanted to follow the execution line by line? If I restart it, we are back at the first breakpoint and only the first message printed, but what if I wanted to follow the age variable closely? Maybe I want to pause before I reassign it and pause again after I assign it and all that. If you are a beginner, I know what you're thinking. The solution is easy, right? Just put breakpoint after breakpoint after breakpoint each line. Because I thought that too when I was a beginner and I'm not ashamed to admit it. But there is a better solution because right now we have to delete the breakpoints when we are done with them and maybe put them again when we want to pause again and so on. There's a better way. To better illustrate this, let's take another example. So If I put a breakpoint here and I run it, I have no message at the console. That's because, first of all, the above codes are methods, and unless we call them, they do nothing. Second of all, because again, the line we are paused at didn't run yet. So if I wanted it to run and still be paused, I'd have to either put a breakpoint on the next line like we just did, or I could press this button here or press F11 on my keyboard. If I press it, the execution advances to the next line. And I didn't have to put any breakpoint, delete it afterwards, all that. If I press it again, the execution seemingly jumps to some random code. But if we look at the line we just left, it was a method call. So that's what step into means. When it encounters a method call, it steps into that called method, into the method we are calling. And we can continue to press step into, the execution will advance into the new method. When it encounters a new method call, it will jump into that one too, and so on and so on. And when it gets back from a called method, it resumes from where it left in the previous one, and so on, and so on. This is useful if you want to follow the execution method call by method call, but some other times you want to get to some place and there are a lot of method calls until there and you don't want to go through all of them and all that. For those moments, we have another button, which is this one, F10 or step over. And if I press it, the execution advances just like before, but when a method call is encountered, it doesn't go into that method. It's not like that method is not executed, it's still called and it still executes, but it's done automatically and instantaneously, and the pause is applied immediately after that call ends. Some other times you accidentally step into method calls, something like this. Now I am inside the body of method 2. And of course I can step over other method calls, but I still have to execute all the instructions in the body of that method. And this is a short example, but if it was a large method, it would take a lot of time. So instead I can press the third button, which is step out or shift F11, which takes me out of this method and gets me back to where it was called. And again, it's not like the method doesn't continue to execute, it does, but it's just automatically executed until you finish that method call and you return where you were before you call it, and it's paused again. So it's a way of, oops, I stepped by mistake inside you, let's get out. Here is a little secret about this. If you are working in a very large project and you don't know where the execution starts, what's the startup file, and you don't want to spend a lot of time, you can always press F10 or F11 to automatically start the application in debug mode and pause at the first line of code in that application, in the entry point of that application. Also nice is the fact that if for some reason you stepped over some line and you want to execute it again, you don't have to restart the application. Instead, you can just drag the execution and execute it again. For example, if you modify the value of some variable and you want to rerun the codes that make use of it, you can just drag the execution there. Another silly example would be if you have a program where you make an API call to make a payment. Maybe you don't want to make that payment actually. Maybe you want to make some tests. You can just drag the execution over that line so you don't execute it. Because yes, the execution can be dragged forward, not just backwards. There are two catches here. First of all, it only works in the current method, so again, you cannot jump to another method like this or in another file. It would be crazy. Second of all, be careful about side effects and unintended consequences, because when you drag the execution, maybe you execute codes in the order they were not intended to, or maybe you skip certain parts that should execute, like initializations and all that. Still related to method calls, in the last lesson we talked about the stack and the heap, and I said there that value types for the most part go on the stack. That is true, but there is a nuance to it. Every time you call a method, the computer creates what's called a stack frame, and inside it stores the method parameters, every value type that is declared inside that method, return addresses and others. So yes, value types do go on the stack, but they are placed in frames that are created every time you call a method, and this can be observed here in this call stack. If I rerun my project, and we pause at the first breakpoint, we can see the first entry, which is hello world.dll. This is the name of our executable. Then program, which is the name of the file where we are in, and .main. But main, as I explained in the previous lesson, is a method that is automatically created for us if we don't create it manually. So it's showing me that where I am paused at right now, I am inside the main method at the line 13. This is the stack frame I was talking about. This is the frame that was created when this method was automatically called. So if I advance the call, nothing changes. But if I step into the next method, it's placed above the main method. So now you can see that we have a new entry called method 2. This is the stack frame that was created for method 2. If we keep calling other methods, they are added themselves. So as long as we keep calling methods, stack frames will be generated and added on this call stack, and their parameters would be placed here and all that. When we end the execution of some method and we return to where it was called, the stack frame associated with that method call is destroyed. So if again we continue and we return from method 2 yet again, it's also destroyed. The only one that remains is the main method, and it will continue until the program execution ends. If you don't see a call stack entry, you can go to Debug, Windows, Call Stack. But be careful, this is a conditional menu entry. So you need to be paused in some breakpoint. You need to be in debug mode to actually see it. If I stop the application and I go to Debug Windows, there is no call stack. So keep that in mind. Why do we need this call stack? Well, you can think of it like a tracing mechanism. We can look what methods needed to be called in order for the execution to get where it is right now. So for example, if I'm in a method called save invoice data, I can look at the call stack and see what methods were previously called to get here. Did I get here through a method called create invoice, or was it update invoice? Did it have an ID already, or was it a new one? So this can help me to understand what path did the code had to take and how did I get there. Maybe it shows me something that is wrong in the method chain that is called, and I can debug it. Another cool thing about the call stack is that if I step inside method 2 and then inside method 1, what if I wanted to look at something inside method 2, but I don't want to end method 1. I don't want to advance the execution or to return back to method 2. I want to remain where I am, but I want to look inside something inside method 2. I can just double click the stack frame for that method in the call stack and I'm back to it. I can look at things, I can do whatever I want, then I can double click the current method again and I'm back inside it. So I can arbitrarily double click any stack frame in the call chain and I jump to that method, which is really cool. Let's take another example. I declared an int array of 1000 entries. Let's consider they are invoices and we store their totals. I want to see the total of the 500 invoice. How do I do that? Well, I could set a breakpoint and I could run the project and then I could click continue 500 times, or I could step into also 500 times, but both of them not really nice options. I could try to modify the value of I to be directly 500, but this only works on the assumption that nothing else uses the value of I inside the loop's body. If something else uses it and needs all the cycles of the loop to run, then I'm in trouble. How do I not click 500 times continue and also not skip the loop cycle? Well, I can right click the breakpoint, go to conditions, and I can set a condition. A Boolean condition which only breaks this breakpoint, only enters debug mode when this condition returns true. So I can click continue and it will go up until when I has the value 500. Isn't that cool? This is also the place where you can set actions. So when your breakpoint is hit, you can perform some actions, and also you can set labels which are text as reminders for you what that breakpoint does. That's really useful when you have a lot of breakpoints spread over many files. So you can go to Debug, Windows, Breakpoints, or this one right here, and you'll see a list of all your breakpoints grouped together, and you can see their labels. You can sort them, you can filter them, search them, everything. You can delete, disable, etc. You can even import and export them as a file, which means you can port your list of breakpoints from one work colleague to another. That's a nice thing. Next, let's discuss the autos and locals, which are these right here. Or if you go to Debug, Windows, locals and autos, but again, these are conditional menus. You'll only see them if you are paused in a breakpoint. What are they used? Well, if I wanted to see the total of the 500 invoice, but I don't have a loop, because sometimes you get the entire array already populated from somewhere and you don't have a loop to iterate through it. How do you do it? Well, you could go to hover with the mouse and expand it and then start scrolling and scrolling and scrolling. But if you so much as sneeze and the mouse goes off, when you go back, it's back from the top. So you have to start over. And that's not really nice. Instead, you can go to autos, which is what Microsoft Visual Studio thinks that is of interest to you in the current context where you are paused. In this case, it's I, because that's the interesting part in a loop, but that's not what interests us right now. So if it's not here, it's always in the other place, in locals. And we can see here we have totals, which we can expand. And we can scroll at our own pace without having to reset, re-scroll, etc. Which is nice. The next panel to watch is the panel next to it, watch, where we can specify variables we are interested in to observe their values. So we can also do this in locals. If I collapse this one, and if I step into, I can see the value of I changing. But what if I have 50 variables in the current scope? I will have a long list here, and if I want to observe two variables side by side and they don't appear next to each other in the list, I have to constantly scroll between them just to see their values. Instead, I can specify them, add them to the watch, and when their value changes, I can see it. You might also be interested in the immediate window, where you can arbitrarily just experiment with stuff. So for example, you can assign values to variables, and now I has the value 100. You can evaluate conditions. You can call methods, you can do many things. So this is a way to experiment with the code without actually having to modify it and restart it and etc. A couple of notes at the end. One is about a feature that is enabled by default in Visual Studio and I personally find annoying and intrusive, Run to Cursor, which can be found by right-clicking and choosing Run to Cursor. But to better understand what I'm talking about, let's revert to the codes we had before and let's go to Tools, Options, Debugging, General, scroll down and enable this, Show Run to Click. And now if I right click somewhere and I choose Run to Cursor, it will run up until that point, which in theory sounds nice. Why should I step over up until that point when I can just directly start from there? But do you see this green thingy that appears on every single line of code that I hover the mouse with? I can tell you how many times I wanted to select a piece of text and I accidentally clicked that one and it shifted the execution to that point and I needed to either revert it or restart the application and all that. Not only that, but it doesn't work in most cases. First of all, because the vast majority of projects you'll be working in are not one file long. They have many files and many of them are event driven, which means I need maybe to click some button to trigger some method. How would Run to Cursor work in that scenario? Would it click the button for me to get inside that method? So most of the times for me, at least for me, it was an annoyance and it's one of the first things that I disable when I install Visual Studio. You can decide for yourself. Second, you may have noticed we have a debug drop down here and If I expand it, we have debugging and release. What's with that? First of all, everything that I explained today about debugging only works in this debug mode. That's because when you select it and you run your program, it is compiled, the executable is compiled with a ton of extra information that helps you to perform debugging and locate errors where they occur. But that also means that the executable is larger and slower because it has other stuff to process. So this only should be used while you are fixing bugs. When you are done and all the errors are fixed, in theory, well, at that point, when you are ready to deliver the application to the client, you want to select release mode and compile it, because release mode is a stripped down version. It's taking away all the debug stuff and optimizes the executable for size and speed to be as small as possible and as fast as possible. But again, you can no longer properly debug it. In theory, I can select release and I can still try to debug it in Visual Studio, but I get a warning telling me that you are in a release mode and you are trying to debug it. What do you want to do? I can force it and I can say it, continue debugging as if I want to debug, but most of the things will not work. As you can see, I get a lot of warnings about not being able to reach this breakpoint because it has no symbols. That's some complicated stuff you don't need to know for now. But again, everything that is debug related only works during debug selection. That was it for today, and I know it is a long lesson. I know it is a lot to absorb, but do strive to memorize all this because it will save you time and improve your performance. It also improved my performance when I was a junior and I finally decided to learn debugging for myself, but that's another story. If you consider that I did a good job explaining these topics, consider dropping a like and maybe subscribe too if you want to see more videos like this. In the next lesson, we will discuss about exceptions. We've seen them before. We will just learn how to deal with them. So until next time, thanks for watching and I'll see you in the next tech frame.